In this video, I'm going to cover resistance in parallel circuits. So here is my circuit diagram. We have resistor 1, 2, and 3. I also put the formula triangle in the corner to remind us where we get our formulas from. So in a circuit, any circuit, including a parallel circuit, our current is always going to be total and is going to be conserved. So that means that we know I total is going to equal I1 going through this wire plus I2 going through this wire plus I3 going to this wire would equal the total current of the circuit. So I've written that here. We also know that I equals VR from our triangle. So if I just write I total differently, it'll equal V over R1. The potential difference supplied will always be constant in this circuit, plus V over R2 plus V over R3. And now I can take these V's out of this equation, so I'm going to say IT equals 1 over R1 plus 1 over R2 plus 1 over R3 all multiplied by V, right? You see how that happened. Now I'm going to take this V to the other side because I'm just trying to get resistance as my main variable. So I take the V to the other side. Now I have I total over V, which is going to be constant, equals 1 over R1 plus 1 over R2 plus 1 over R3. IV, that's interesting. What does that look like? So we know that R from our triangle, R equals V over I. And on this side, I have I over V. So if I take 1 over R, that gives me 1 over this, or just the inverse, so flipping it, gives me I over V. Now I have I over V and I over V. So I can rewrite my formula as 1 over R total, because here in this case we're using I total, is going to equal 1 over R1 plus 1 over R2 plus 1 over R3, right? And that's how we derive that formula.